Hello friends, I'm Sarita Verma and welcome to my channel Electronics Simplified. Today in this video, we will be discussing types of communication systems and modulation. The contents are objectives, communication systems and information signals, modulation, need of modulation, the types of modulation which includes amplitude, frequency and phase modulation along with digital modulation, a comparison of A.M and F.M, applications of A.M and F.M along with a small quiz. This video has been developed with the objective that after watching this video, the learner should understand the need of modulation, classify modulation, define baseband signal and different types of modulations, draw waveforms of different types of modulations, compare A.M and F.M and enlist the applications. What is a communication system? We know that it is a means of conveying information from one place to another. Now, information signals can be either analog or digital. Analog signals are those signals which continuously vary with time. All signals which exist in nature, most of them are analog in nature. Voice signals, picture, music, etc. Digital signals have only two distinct levels, high designated by 1 or low designated by 0. Signals obtained from a computer are digital signals. Now, let us classify the communication systems based on the technique which is used for signal transmission, baseband transmission system or communication system which use modulation. Let us now first understand what is a baseband signal. So, the electrical equivalent of your original information signal is known as the baseband signal. That is, when you convert your information signal into an electrical signal, the output which is obtained is the baseband signal. The baseband signals are directly transmitted over your telephone lines as voice is transmitted over the telephone network. And the type of transmission which occurs is baseband transmission system. Now, this system has its own limitation. That is, when your baseband signal is to be transmitted using free space as a medium for transmission, the voice signals get suppressed after a short distance with time. So, if we were to transmit baseband signals using radio communication, we need to adopt a technique called modulation. And the type of system will be communication system using modulation. Now let us understand what is modulation. For modulation, we need two signals. One is the baseband signal, also called the modulating signal or your information signal, which is a low frequency signal. And another, a high frequency signal, which is called the carrier. To understand modulation, let us consider a small example. If we were to move from your home to your workplace, you can different modes of communication. One, you may walk all the way, or you may use a vehicle which may be either two-wheeler or a four-wheeler, right? So you are the modulating signal and the vehicle will act as your carrier, which will be a high frequency signal. Fine. When you move from your home to your workplace, does any change occur in you or in the information signal? No, you are just superimposed on the vehicle. Same way, in modulation, the information signal is superimposed on the carrier. No change in the information signal will occur. The carrier, which is your high frequency signal, either we will vary the amplitude, frequency or phase, and so process of varying some characteristic of your carrier signal according to the instantaneous value of your information signal is called modulation. Modulation is nothing but adding information to your carrier signal. Here is the block diagram of a modulator. You have your baseband signal, which will generate your information or the modulating signal, RF oscillator which will generate a high frequency carrier signal, and the output will be a modulated signal which will be superimposing the information signal on the carrier and then that signal can be transmitted after amplification through a transmitting antenna. Now, why there is a need for modulation? If we were to transmit voice signal as it is, a large size antenna would be needed as antenna height is proportional to the wavelength, 1/4 of the wavelength, right? So the size of the antenna will be more than the distance between the transmitter and the receiver. So modulation can help us not only in reducing the antenna height, but avoid mixing of signals, increase the range of communication, allow multiple signals to be transmitted, as well as improve the quality of reception. Now let us see what are the different types of modulation. So we have continuous wave modulation and pulse digital modulation. In continuous wave modulation, again we have amplitude modulation and angular modulation. Angular modulation again can be classified as frequency modulation and phase modulation. So depending what type of information signal we have, whether it is a continuous wave signal or a pulse signal, right? If your information signal is in the form of pulses, then we have different type of modulation. One is digital modulation, which includes pulse code modulation, and in analog modulation, we have pulse amplitude modulation, pulse duration modulation, and pulse width modulation. Now let us see what we mean by amplitude modulation. In amplitude modulation, the amplitude of the carrier signal will be varied, not that of the information signal. According to what? According to the instantaneous value of your information or modulating signal. So we are going to represent the message or information signal by MT and the carrier by CT, that is A cos omega CT. Fine. Now let us see, this is the information signal, this is the carrier signal. Information signal is a low frequency signal, carrier is a high frequency signal. Now we are going to vary the amplitude of the carrier according to the instantaneous value of our information signal. Instantaneous means our information signal is varying continuously at every instant. So as the amplitude of the information signal increases, the amplitude of the carrier will increase. And at the maximum peak, the amplitude or the amplitude modulated signal will be maximum. And during the negative peak, the amplitude will be minimum. Fine. So this is your information signal, a carrier signal, and your amplitude modulated waveform. Now let us see the frequency spectrum of amplitude modulated signal. So you have your carrier signal and your upper sideband and lower sideband for your amplitude modulated signal. This is called the upper sideband and this is the lower sideband. The bandwidth of your frequency spectrum of amplitude modulated signal is given by upper sideband minus lower sideband, FC plus FM minus FC minus FM. So bandwidth is given by twice FM. This is the simulation for your amplitude modulated signal. Now, just like amplitude modulation, we also have frequency modulation. In frequency modulation, the amplitude and phase of the carrier are kept constant. Only the frequency of the carrier signal is varied according to the instantaneous value of your modulating signal. So you have the modulating signal. This is the carrier with a high frequency, and this is your FM modulated signal. This is the simulation. So here you can see, as the amplitude of your information signal is changing, the frequency of the carrier is changing. Amplitude frequency modulated signal is represented, right? As the amplitude of your information signal is increasing, the frequency of the carrier is increasing. And at the maximum peak, the frequency modulated waveform will have maximum frequency. At negative peak, it will have minimum frequency. If you see the frequency spectrum of an FM modulated signal, that is given by twice n into FM, where n is the number of sidebands. In FM, the frequency spectrum has infinite number of sidebands. In AM, we had just two sidebands, upper and lower sidebands. So, if we were to calculate the bandwidth according to Parsons rule, then it is given by 2 into delta plus FM. So this is the simulation. Here you can see as the information signal value is changing, the frequency of the carrier signal is also varying. In phase modulation, the phase of the carrier signal will vary, whereas amplitude and frequency will remain constant. So this is your information carrier, and the phase of the carrier signal will vary according to your information signal. This is a comparison between AM and FM. So we know that FM receivers are more immune to noise and the AM are less immune to noise because noise signals may get added to your amplitude modulated signal. Then bandwidth is higher in FM and depends on the modulation index, whereas bandwidth is lower in AM compared to FM, right? Yes, the transmission reception equipment for FM are much more complex compared to AM, and all the transmitted power is useful in FM, whereas in AM, only the carrier part and one of the sidebands, because both the sidebands are mirror images of each other. If you see the applications of AM and FM, AM is widely used for broadcasting, that is for your long, medium and short waves. We know that we have AM and FM radios. VHF transmission for many airborne applications, and it is also used for broadcasting video signals of television. FM broadcasting, you have your FM radio you must be hearing in your day-to-day life, radar, music synthesis, along with video broadcast systems. FM is also used for broadcasting sound signals of television. Here is a small quiz which you need to solve to test how much you have understood. Thank you.